I'm going to tell you a bit about the bee observer project and about our current state of the data analysis. So within the bee observer project, we also have a sensor set up for bee colonies, and it's DIY. So everybody should be able to use our manuals without any special skills to build it themselves. And we have 5 temperature sensors within the hive and 1 temperature sensor outside from the hive, and a humidity and pressure sensor, and also a scale. And then we are also using the Beep app or a fork of the Beep app so that the data is collected on our server, and all beekeepers can see their data. It's still in the old version. And this is a bit about the history of Bob. It was a research project funded by a German ministry from 2018 until 2020. And it's always been a citizen science project. And now that there's no official funding anymore, it still continues as citizen science project. What does this mean that it's a citizen science project? So basically all the work in the research process is done or at least supported by citizens. So for example, beekeepers come up with the research questions, and of course they also collect the data. Then we have Maker, for example, a group in Berlin called Hive Eyes, and they created the hardware and the software. And then we have data scientists, and therefore we collaborate with an association called Coral 8, who do data science for good. And of course, we want to support the DIY manuals and the open code, but we also hope that we can support beekeeping with the data and AI algorithms, and possibly learn about the factors of bees' health. So now I'm coming to the data analysis. And the first step in the process of data analysis for us was to look at anomalies. And it's a bit like this new feature in the Beep app that you can have basically cut-off values and then alerts. And we used so-called ARIMA models. So basically, we look at the difference between one value and the next value, and look if this difference between those values is similar to the differences before, or if there's a sudden increase or decrease. And then we say, okay, this might be an anomaly. But the challenge for us at the moment still is to define how big the difference has to be to have an important anomaly, and how many of those anomalies should we report to the beekeeper. And we also believe that this might even differ from bee colony to bee colony. So maybe our algorithms have to be adjusted for that, and to be different for every colony. And then we also try to find anomalous trends. And for example, we want to predict swarming. And in our data so far, we had only or at least 11 swarming events, but I think it's okay to start with that. And then, of course, we have reference data from colonies which didn't swarm. And during a swarming event, of course, the rate drops. And here you can see the temperature. It's the mean temperature for the swarming colonies. And you can see that it's actually increasing already a bit before the event and during the event. So that's like one feature of swarming. And now the question is, might there be something special already some hours or days before the event, which we cannot see with our eyes, but maybe algorithms might be able to detect this. And therefore, we tried a k-nearest neighbor algorithm. So, for example, if you want to find out to which group the question mark belongs, then we can look at the k or 3 nearest neighbor. And in this case, there are 2 green squares in this group. So we say, okay, maybe it's a green square as well. And we do the same with the sensor data from our bee colonies. And the distance measure we use for that is called dynamic time warping. So we are not using Euclidean matching, where we would look at 2 exactly same time points, but basically we try to match the peaks in the different sensor data. And so far the results are promising. It seems to work. We did have an accuracy of 80% one day before swarming in our first tests, and yeah, we are in the process of publishing it on a conference, and yeah, hope we can still improve it. I think there's still some work to do. For example, we want to make sure that actually the weather conditions between the groups are comparable as well, so that the accuracy measure is fair, basically. And I also believe that the weather data is really interesting for swarming prediction. So I want to focus on this because I think only looking on the weather data can tell you already a big deal of swarming probability, and then we can have the sensor data to support this. So we might even have a research project in BEEP for that. And then we want to improve the accuracy and also the exact date and time prediction, so that we are not only able to say, okay, there's a swarm maybe tomorrow, maybe in 1 week, but that we are on, exact on that as well. And then, of course, we want to integrate it in the app. And possibly we can use the same approach to look at dying colonies, but so far, luckily, we didn't have that many dying colonies, so we cannot test that yet. Yeah, so far from me, I hope it was understandable, and I'm looking forward to your questions and your feedback.